All right, welcome in. We're going to go through some examples here about similarity, and that's the new unit that we're in. We're going to study similarity with triangles, mainly because triangles is the simplest shape, okay? So you can build every other shape, every other polygon with a triangle. We're going to start there. We know some stuff about them already. All the interior angles add up to 180 degrees. We're going to make some more observations about how two triangles are determined to be similar or not similar. So, we're gonna spiral back. We're gonna use this document here. Looking at the triangles, we're gonna investigate a little bit and see if we can come away with a big idea. So when you're done with this video, you should understand some basic things about observations with similar triangles. All right, so that word similar that we've got, that has a mathematical meaning here, okay? Two triangles are similar. We don't just say, hey, because they're both triangles, they're both kind of similar. What we want to dive into is what are the characteristics that those triangles would have, okay? So we can investigate the angles and we can investigate the sides and the relationships there between the two. So as you can see, we've got two triangles on our paper here, and there's some markings there. So right off the bat, I can see that the angles seem to have those little markings there, those little arcs with little hash marks there. And so you can kind of tell that, hey, there's some angles that are marked the same way in both of those triangles. Turns out that all three angles in both of those triangles are the exact same measure. I don't know what the measure is, but I know they're the exact same. So that tells me that the angles are congruent. When angles have the same measure, the angles are congruent. When the angles have the same measure, the angles are congruent, okay? Now the sides are not the same size. I'm gonna go ahead and highlight the smallest side on the triangle on the left here. So I'm gonna highlight that in this color red. And then I'm gonna go to the other triangle and highlight the smallest side on that triangle. Looks like we got 24, 32, and 12. So this would be the smallest sides on either triangle. And then let me pick a different color here, maybe green, and highlight the biggest side. I'm gonna highlight the biggest side here is 16, and the biggest side on this one is 32. Okay, and then that third side here, let's choose, I don't know, blue. Let's go with blue. That other third side, that medium side length here for either one. Okay, so what I've done is I've just matched up the side lengths. I knew all the angles were congruent. What about the side lengths? What's going on there? All right, so the small side lengths were 6, 12, and 16, and the other one was 12, 24, and 32. So there's a relationship there between the small side and the big side, the small side on the left triangle and the small side on the other triangle. Same thing with the mediums, and we can compare those. So see if you just looking at those, comparing the red sides and the blue sides and the green sides, do you notice any sort of pattern that sticks out to you? All right? See if you notice anything there. So what sticks out to me is when I compare those side lengths, let's see if I can get that color, that blue color again. When I compare the side lengths of the big triangle versus the small triangle, 24, when I divide that by 12, okay, I get 2. In other words, the triangle on the right is twice as big when I compare those side lengths. Now, if I did 12 divided by 24, I would have gotten a half. But if I take that big number on the big triangle and divide by the smaller triangle, I get 2 on that side. Let's see if that's true for the other one. So let's go back to the red. Let's see, if I take 12 on the bigger triangle, that's the red side, and I divide that by the smaller triangle sides, red side, 12 divided by 6, well, that's also 2. And then what about that green? What about that green one? 32 divided by 16. So 32 divided by 16, well, wait a second, that's also 2. So I get this consistency in the side lengths. It's called the proportionalities are the same. The proportion is the same in both triangles, all right? So we can see visually that the angles are congruent. The side lengths are proportional. And that's what I was showing there when I was doing all that division. I was comparing the side lengths, right? So the red sides that we matched up, those small sides, the way that they relate to one another, one's twice as big as the other. And it's like that for all three sides. And so going back to our definition of what it means to be similar, what are two triangles are similar if, and we can write this out. Two triangles are similar if the corresponding, and that means matching, corresponding angles are congruent, meaning they have the same measure, are congruent. All right. This would be something you would write down in your notes, by the way. Also true, the corresponding matching. So when you see that word corresponding, you should be thinking, oh, I'm either like matching the angles or I'm matching up the sides, like when I did the highlighting thing. So the corresponding sides, they're not congruent. They're not the same size. Corresponding sides are, we call it proportional. Okay, so you may have seen that word somewhere before. So both of those facts are true about similar triangles, okay? So what you need is you need to make that definition about corresponding angles being congruent and corresponding sides being proportional. You need some practice with it. You can't just hear it once. Oh, he told me, so now I know it. You got to practice a little bit with it. And so this document, which is available to you on, I'm going to try to link it in the YouTube page. I don't know if that's possible. Otherwise, it'll be available on Canvas. But we're going to match the congruent angles. We're going to write a similarity statement and go through all that type of stuff. So we're going to try to make some more connections there. So look for the next video on continuing this piece. Good luck.